In 1797, one man set out to achieve the impossible, to weigh the entire world. He wasn't a king or an emperor, but a shy, reclusive scientist named Henry Cavendish. His audacious goal stemmed from a question left unanswered by the great Isaac Newton himself. Newton's law of gravitation described how gravity worked, but a key piece was missing. To solve it, Cavendish needed to measure the gravitational force between two known masses. The challenge: this force is incredibly, almost immeasurably weak. The slightest disturbance would ruin everything. So, Cavendish built an apparatus of extreme sensitivity, a torsion balance, locked away from the world. Inside, a 6-foot wooden rod was suspended by a single delicate fiber of quartz. At each end of the rod hung a small 2-inch lead sphere, perfectly balanced. Then, two much larger lead masses, each weighing 350 pounds, were brought near. In theory, their gravity would attract the small spheres, twisting the delicate fiber. The experiment was so sensitive, even Cavendish's own body heat would create interfering air currents. His solution was extreme. He would operate the entire experiment from outside the sealed room. He used specially designed rods and pulleys to move the heavy weights from another room. To measure the twist, he couldn't enter the room, so he built telescopes. He mounted a tiny measuring scale, a vernier scale, on the end of the rod. Peering through his telescope, he would watch for a movement of less than a millimeter. For hours, days, he waited for the apparatus to settle, his patience seemingly infinite. He moved the large masses into position, his heart likely pounding in the silent observation room. Then, a tiny, almost imperceptible rotation. The gravitational attraction was real. It was working. He meticulously recorded the deflection angle, a testament to his extraordinary precision and patience. He measured the faint twisting force, the torsion, by observing the rod's oscillation period. With these tiny measurements, he now had everything he needed for the grand calculation. He related the force between the spheres to the force between the Earth and an object. The force on the surface is its weight. The only unknown left was Earth's mass. After analyzing 17 delicate measurements, he calculated the density of the Earth. His result, 5.448 times the density of water, an astonishingly accurate figure. The modern accepted value is just 1% different from what Cavendish found 2 centuries ago. His experiment was posthumously called weighing the world. But he had done something more profound. He had revealed the value of g, the gravitational constant, a fundamental number of the universe. With g, humanity could calculate the mass of the sun, other planets, even distant galaxies. Cavendish himself was indifferent to fame. He never announced his revolutionary discovery to the public. He was a scientist's scientist, driven purely by an insatiable private curiosity about the world. His work remained in his notebooks, largely unread for nearly a century after his death. It was James Clerk Maxwell who later edited and published Cavendish's papers, revealing his genius. The story shows that great discoveries often require removing oneself from the noise of the world. Cavendish's extreme methods were not madness, but a necessary condition for an impossible measurement. He proved that with enough ingenuity, even the grandest secrets of the universe can be measured. From a tiny twist in a sealed room came the mass of the Earth, a quiet man's quiet experiment that ultimately screamed its importance across the centuries.